So today I will walk you through how and why we had to manage to get CDRs from our core network, which is an IMS, as Daniel mentioned, and we run mission-critical push-to-talk applications over it to our billing mediation finally. So this talk is without AI, legacy, pure coding stuff. So it's a bit old school. About the agenda, first a few words about Kontron, myself, then about the architecture. Our implementation is based on the RF interface itself. So we basically extended the IMS charging module, which was existing for the RO, the online charging. Few things about how we trigger the RF messages through SIP. Then a few call scenarios where you can also see some samples. A few things about the configuration we do in Kamailio to support this interface. And finally, we also did a built-in RF messaging tool, which we can trigger through kamcmd. Okay, Kontron Transportation. So I said what we are doing. We are basically doing end-to-end network solutions for mission-critical entities, mainly railways, public transport, or other blue light organizations. And we in Vienna are basically developing the core network. And yeah, that's it, what we are basically doing in our team. And a few words about myself. I'm Roman, part of the Generation X. I started also quite some time in telco development. The younger people or younger folks wouldn't even know. I started in 2G circuit switched domain. I moved then to 3G UMTS and packet switch domain. And in around 7-8 years back, I've started with IMS, MC, PTT, this mission critical push to talk. And that was also the days where I get in touch with Kamailio, where our IMS is built on top. And yeah, I like DevOps, and usually when I'm not at work, I'm at rock concerts. Okay, the architecture we are using. It's just a high-level diagram, but you will see that we have the CSCF. All the CSCF nodes in our deployments are based on Kamailio. We run our HSS, which is the database. And we have a couple of application servers, one for normal telco and one for legacy telco, like the MMTel services for forwarding and all that things. And we run a specific one for mission-critical push-to-talk application. And you see the RF interface here. The specificity is that we just have an RF interface from the CSCF, from the S-CSCF, and all the information from the application servers we pass through the S-CSCF, and we finally put it then into the diameter interface. So on the right-hand side, you have a couple of specifications the RF interface is based on. And yeah, we as said, we do not have, as typically you could also have RF interfaces from the application servers towards the charging systems. So the CDRGen is the offline charging system. It's from various vendors we have integrated. And at the very bottom, you see the billing system, which we per se do not use because our customers are mainly using the CDRs for statistical purposes. There is no billing or to pay per se. Few words, online, offline charging. As said, the IMS charging module already supports the online charging. It's for services where you have to to check the credit control during the service. And the network must, let's say if your balance is gone, the network must cut the call or drop the call. While in offline charging, it's event or session record based, and its charging happens after the service. So that means there's no real-time control, and that's also a good thing for us because it's not that complex. And finally, data is stored in the CDRs at the CDF-CGF function. The key difference, yeah, as said, postpaid and prepaid for the online charging, where you have to check during the service if you have enough balance or not. the logical charging architecture. As said, there is this CTF, the charging trigger function, which we have implemented basically, or which is hosted on our S-CSCF. It finally gets triggers due to SIP messages, we will see a bit later, and will then trigger RF messages, which are based on diameter, towards the CDF-CGF, which is typically, at least the vendors we have worked with, in one box. And at the far end, we have the billing domain, which is our billing mediation. And why are we still doing it, let's say, in those days? On the one hand, our customers, which are still networks using legacy technology, GSM, so 2G technology, they have this billing mediation where they have our records from this legacy world, and we have to feed basically also records now from the IMS-based successor network, because there are several years where they have to interwork, and that's a good thing for them, that they can correlate calls from one system to the other system. Okay, RF interface. We have, in principle, two diameter messages, the accounting request, which is basically the charging data request, and the answer, which is per se the acknowledge to the request, and it's triggered from the CTF, so in our case from the S-CSCF Kamailio based, and it's sent towards the CDF function. A few things which are included, but it's really only high level. It contains the SIP method, which triggers basically the diameter message, can be publish, register, which are event-based, or invites. And the answer will contain per se only, only result code if it was successful or not, and is basically an acknowledgement to the request. Compared what was available in RO. In RO, these messages are basically called credit control request and credit control answer. So CCR and CCA, while here we have ACR and ACA. What else? In the RF interface, like in all diameter-based interfaces, you have the AVP, which is the attribute value pair, also per a specific standards, which would be 23299. What is it? It's structured like the attribute, which is the parameter name, and then you have the value, the actual data inside. While MCPTT is quite specific, because in MCPTT SIP, you have various payload XML bodies, which contains this specific information for this mission-critical push-to-talk, or mission-critical video, or mission-critical messaging session. And everything goes through our S-CSCF, and in Kamailio we pass basically these payloads and extract them and put them into vendor-specific AVPs, a part of the standardized AVPs. Like subscriber info is included, session information, the SIP details again, which SIP method triggered those diameter message, media details. And on top, as said, we have these specificities for the mission-critical information. Yeah, we have charging types and scenarios. In the offline charging, you have basically three types. You start, triggered by an invite, for instance, and then you have the stop, which is basically due to buy failure or timeout. And on top, you have this interim, because if you have, let's say, a long-lasting call, then you have interim updates where you can then create interim records as well. And you have this event-based charging, which is standalone, not standalone SIP messages like publish, register. For instance, in our system, first the user registers in the IMS, and further on, the MCPTT application sends a publish through the IMS towards the application server to publish and to the MCPTT service, and can use it then. So event-based, as said, standalone SIP messaging, and the session-based is basically during calls. Okay, yeah, what are the key takeaways for the interface itself? You have just two messages, the request and the answer, which are basically the envelope. Then you have the AVPs, which is basically the information, the metadata, and everything inside, so the value pairs. And finally, this information is parsed to the charging gateway function, charging data function, and there the CDRs are generated and can then be sent towards post-processing, like the billing mediation. Okay, how does the trigger work? So the call flow, I don't know if it's too small, probably. You see it's a session-based charging where on the left-hand side, the service request, kind of an invite is received, and after the 200k for the invite, we will see a diameter message towards the charging gateway function. We can have this optional interim, which could happen even during long duration calls, or if you update media or something like that, then you would have this interim record, while when the user or one of the users sends a buy, then the session will trigger a closing of the CDR. And this is basically the session-based charging. The event-based charging, as said, in this case it's just a pure IMS registration, would trigger one record for the user. If you have a publish afterwards, you would see another event, so basically two CDRs. Okay, this table gives you just an idea, an overview how we trigger the RF messages. So as said, the 2XX acknowledging an initial invite will trigger this ACR, or an interim will be a re-invite or an update, what I've just mentioned before. The accounting request for the events, as said, as example, I showed you the zip message, zip register, refer, notify, so all those kind of things. And I have also, I think, then later on some further diagrams. And this is basically how it works from the user equipment. User equipment triggers zip messaging or zip signaling. It's forwarded through the IMS, finally towards the CSCF. And the CSCF, as said, based on the triggers we have seen before, will issue these diameter requests towards the charging data function. And finally, on the very right-hand side is our post-processing. However, it is called, in our case, it's called billing mediation in Kontron. This is also a snippet just to see how it looks like for those who have not seen diameter requests or diameter messages at all. And here you would see that it's an event-based record because it's triggered by the register message from the UE. You have several information in the IMS AVP, and here you have this specific event type that, what I said before, it includes also the zip method, which was triggering these diameter messages. And of course, you have then all these subscriber identities and information like that, session information inside. This is a bit a kind of session establishment, so a private call, a point-to-point call between two UEs. You see on the right side, we have this MCX application server. And why is it important? The MCX application server in our deployment acts as a back-to-back user agent. That means you have two separated legs, ORIC and term legs. This shows you the ORIC leg. And you see that two AC accounting requests are basically generated. So one is here. This is the first one for the called user, and the second one for the calling user. And on the right-hand side, I have moved then from terminating role, because this is the terminating S-CSCF, while on the second record it is the originating S-CSCF. And both are triggered due to invites. And yeah, both are basically indicating the start of the record. And this is then when one of the users, in this case it's user equipment B, disconnect the session, and again you will see two records, two ACRs, because you have one for the terminating CSCF and one for the originating CSCF. This again in a different format that you see. We have CDRs for the ORIC leg and CDRs for the terminating leg, and then the very bottom, this is what you have on our billing mediation, because these generated CDRs have different roles and different information, but they have the same charging ID. That means that the billing system can finally correlate the CDRs and that they are belonging to the same session call. What's important, as said, we are in mission critical area. That's why we have charging must not break calls. That means it really completely separated if there are diameter outages, even though we have HA setup, even with geo-redundant setup, but charging must not break calls. So diameter outages must be handled completely different and independently from the SIP session handling. That's the key for us. Of course, we have retries buffering mechanism, and we have counters to detect alarms or to detect problems through alarms. But at the end, it's important that the call is established under whatever circumstances in our domain. Yeah, how Kamailio helped us. Of course, a majority of the work was there with the IMS charging module. As said, it was only supporting online charging. So our own interface, so we extended it for our needs. It's not yet in production. It's at the moment at one customer under validation, let's say, and if all goes well, then we will anyway issue pull request. Yeah, charging module is dependent on, of course, a few other modules, important the diameter ones, and we implemented a feature switch, which is basically used for customers which do not have the need for this interface, because it's also not interesting for each and every of our customers. Oops. There's nothing specific. It's configured like any other diameter interface in XML towards the charging gateway function. One specificity we are doing is for diameter we use SCDP as a transport protocol. We do not use TCP, also due to reliability and robustness reasons. We also have this DB mode, and we only do support one. We basically store all these sessions in a database. In our case, we are using a Galera cluster which replicates locally, and we distribute also the data on other geographical sites via asynchronous MySQL replication. And yeah, all relevant data for the RF sessions are stored there, and once the session is over, it gets deleted from the database. And yeah, this is what I've just said. You just specify, in our case, this Galera cluster. Yeah. This RF forced peer, we reused also from the RO interface. It's just good. We use it only for testing purpose, because typically we configure all the diameter peers in the XML, and when you use this forced peer, you cannot use redundancy, for instance. So you force the Kamailio to use always this diameter peer. Expiry also, and a few other, let's say, configuration parameters which are available for the diameter configuration. Yeah, then displays, counters and statistics. Of course, we have also some runtime statistics which are exposed by the IMS charging module, and we implemented specific counters for our needs, which counts initial ACRs, interim ACRs, final ACRs, successful, unsuccessful, all that kind of things. If there are failures with timeouts, all these counters are basically implemented, and yeah, you can see them here. And of course, we also expose a REST interface towards our network management system, which is based on OpenNMS at the moment. It gives the capability to transfer these counters in various intervals via HTTP or HTTPS. And the authentication for this REST interface can either be credentials, or we can also use JWT bearer token authentication for this REST interface. Alarming, we have two types. Basically, what we also use on CX interface, which this time interface towards HSS, specific for the permanent failures. The Kamailio will not use the adjacent peer for any upcoming further messages. Again, this will also be transferred to our network management via REST interface. And then we had an interesting thing, the CDRGen tool. Why we did it? Yeah, it provides basically via kamcmd the possibility to generate massive CDRs without having real zip traffic. This helped us a lot to validate the CGF throughput, and also finally on the billing mediation side, and we use it still for easy regression and maintenance testing when we do bug fixes on new releases. So that's the CDRGen tool. It has start command. Basically, it's configured in an XML. I will show in a second, if time allows. Yeah. You can query if the tool is running. You can parse the XML file for syntactical errors, and you can kill it if for whatever reason, if it gets stuck or. For this purpose, we implemented two mod palms. So the CDR config file. So basically the location of this XML file, and also we can set a limit, a system limit. Why are we doing that? This system limit tells that the user in the XML cannot overcome this system limit, not to, let's say, kill complete CSCF Kamailio just while running this tool. So that's why we implemented this system limit. And is the base structure of this XML configuration. You have at the very top, you have these iterations, basically how often you run this call scenario. Then you have some common information which will be used throughout all of the scenarios you configure in this XML. And then we have service information which has a limit of 16, and there you can have then specific this for the scenarios. But I'll show you in a second more. Yeah, common information, you have a set session ID called calling party. The called calling party is then iterated depending on the amount of load you set. And you also have the STP offer answer there. And you have then tons of information for AVPs you can set in the service information as well as in the IMS information, which is the MMTEL. This is simple. Just a simple XML snippet for just register zip users. So that means this, when you run this via CDRGen, it will basically generate two ACRs for the two registers. You have an interval and a delay where we can basically with the interval you can set the call holding time, how long the session lasts, and the delays, how fast the publish or register come each after the other. Okay, let's see if this works. So I will briefly show you how it looks like. I will open. There are two windows basically. On the top, I will show you the XML file, while on the bottom, I will run a T-Shark that you see how this corresponds. First, yeah, let's go to the location of the file itself, the CDRGen XML file, which is you will see we have iterations, I think 10 if I'm not mistaken, you have these AVPs for the common. We have the SDP answer offer configured, and then we go down to the service configuration where we have then specificities, so we can set the SIP methods like for the events basically, which we want to achieve. What else? It's worth to mention. We have all these informations for the invites, basically. So here you set really the AVPs which you want to have in the triggered ACR messages. On the back end, we have a simulator just acknowledging those, so there is no validation ongoing in this case. In our labs, when we really test, as said, towards real CGF, then the idea was to measure the throughput on the adjacent node. Here I will just parse the XML command for syntactical errors. It will just show you, okay, how many iterations, what's the limit set at the moment, and as said, this duration, the interval, and in milliseconds, so how fast the registers are considered, and the seconds is basically the call holding time. And now let's, have I set it up? It's so small here. I will do now this Wireshark. This is nothing. Is it stopped now? Yes? It's not doing anything, is it? You don't see it because the progress bar is there. Fuck. Yeah. So I've started now the Wireshark T-Shark on the bottom, and I will just do a start now of this XML file, and you see all the accounting messages and answers basically, which are triggered. On the query, you see the tool is busy, while once it's finished, it will show you the idle state. Okay, key takeaways. The RF interface we have implemented in the charging module provides standardized offline charging for IMS networks. For us, the S-CSCF was the best choice for the trigger function, as all the applications are going through it. SIP diameter and CDR is deterministic. So let's say you know SIP input and what you get under which circumstances, what you get on the diameter output. And CDRGen enables for us repeatable mass load generation without having real call processing. Thank you.
Thank you, Roman. I think I was missing something like the pull request link.
Yeah, it's coming. I told you.
Okay. Questions, of course. Anyone? Where we are?
Sure.
Yeah, to be honest, I've never worked with IMS, but I've just noticed that you're not logging like setup time, like your start accounting just with answer, which just makes sense. But you're not logging in CDR, not saving any setup time before the answer.
You have timestamps. Whenever the SIP message arrived, you put it in the CDR, in the diameter, and finally you have it in the CDR.
So you correlate like at the end, like
yes.
The CDR and
yeah.
Okay.
A question at the back or not? For stretching? Another questions about IMS charging? You want it? One? No? Okay. No. Okay. Thank you, Roman. Thank you so much for sharing this and preparing